Welcome to SER321, Principles of Distributed Software Systems. And today we're going to take a look at unit number 1 in the schedule. So if you go to the detailed schedule page, the first unit is about Linux, and we're going to talk a little bit about Linux and different aspects of command line tools that are available in Linux. In terms of reference material for this, you'll see we'll look at some inside of this PDF, but from the detailed schedule, if you either go to the class notes or go to the PDF associated with it, there is a lab exercise associated with this session. It's actually both Unit 1 and Unit 2. Today we're just going to, or in this unit, we're going to talk about dealing with the command line and the Unix file system. And then next in Unit 2, we'll look at doing Java and C++ programming from the command line. So if you take a look at the PDF file, I've actually got it loaded up in a different window. There we go. Here's what it looks like. Maybe I can boost up the size of that a little bit. There we go. So we are looking at let's go ahead and take a look at, I don't know about the outcomes for this section and references. We're actually primarily looking at the basics of Bash today. And then in the next unit, we'll look at compilation, both C++ and Java compilation from the command line as well. So let's go and look at outcomes for the session. This is actually for both Unit 1 and Unit 2. So the first thing is familiarity, and to give you some reference for the common commands that are available from the Bash command line processor. And we are going to work this semester with the GNU C compiler. There are about 10 different languages. C compiler is a family of different languages, and we're going to be working with the C++ version of that, which is called G++. And we're also going to work with Oracle's Java compiler. Actually, so there's a little bit of a difference here, because with the development environment, we're going to be working with Oracle's version 1.8, but on the Raspberry Pi, we'll just settle for the default JDK, which gets loaded, and I think it's 1.7, and I think it's open JDKs instead of being Oracle's. We're also going to look at, so from the command line there's a debugger available which provides the exact same capability that's available from an IDE, a little bit more difficult to get to, but actually a little bit more convenient when it comes to debugging distributed programs. And the same thing exists for Java as well. So we'll take a look at both of those. And then since it's kind of a pain, not kind of, it is a pain, laborious to do a lot of typing in the command line. We're going to take a look at some shortcuts, and in particular when it comes to doing building for a project. We're going to look at the two most common tools that are used for building, although I'm beginning to think that ANT may not be the most common anymore, but it certainly is the most rudimentary, the simplest and easiest to learn first time. And Make, on the other hand, is primarily for C-based programs. We'll talk about ANT here in just a second. Make is primarily for C-based programs. So almost any extension that you make to your system for any set of tools actually comes configurable and makeable. And we'll take a look at the package handlers that are used. They almost always use Make, so I at least want to give you an introduction to Make. We're not going to use Make to build C++ programs, although that would be the natural for C++. Instead, we're going to use ANT because it has an XML specification of what the tasks are to be performed in building. So when we have, so this semester, we're not going to be building programs that have just one file or two files. We're going to be compiling programs that have 10 or 15 files. And in fact, 2 or 3 programs are going to work together, and they may each have several different source files. So we're going to use this ANT tool to make it easier to do the compiling, and even in some cases to do the execution for us of fairly complex programs. And that's a very common thing to happen in the industry. So we'll get a familiarization with ANT and Make. and then understand and utilize and configure the runtime environment for C-based languages. That's particularly more interesting for C than it is for Java, and we'll see what that's all about as well. Okay, so references. There are some tutorials that are available, and they are referenced on this 1.A.3. So there's a tutorial for Bash that I strongly encourage you to take a look at. Bash is the command line processor that's available, and we're using LX terminal running Bash. And then Unix programming tools. This will be for the next unit, for unit number 2. And GCC, or the GNU C compiler tutorial. There's a tutorial for that as well. These are both PDF files that are available through the class website. And then also there is there are 3 or 4 examples in this section of projects, and they require different compilers. So no Objective-C, but the Java Standard Edition JDK has to be there, and then on let's see, the GCC compiler. All right, and those are both described in the configuration. We'll take a look at those in more detail at Unit 2. Okay, so let's talk about Bash. And the first thing I want to talk about with Bash, a few different things here. Working with Bash requires that you know something about the underlying file system, if nothing else about its organization. So I want to, and that becomes particularly important for C and C++, because C and C++ were created at the same time that the Unix and Linux the Unix and Linux systems were evolving. And they are intertwined, literally intertwined. The part of the Java language that depends upon the underlying file system is very simple, and it has to do with packaging. Where we store packages, it has to do with the relationship between .java files and .class files, and this notion of a class path. And we'll talk about that in a little bit more detail, but that's as far as it goes. But it's not the case with C and C++. So in fact, one has to know something about the underlying system in order to have a real good understanding of why C++ reacts the way that it reacts in different situations. So let's see, let's just take a look at Emacs here. Just to give me a blank screen. So in particular, what does a Unix file system look like? Well, let's just kind of draw one. Similar to Windows, it is rooted, meaning that there is, in Windows, there's a C colon as a drive. Well, in Unix, it's called root. And root has subfolders, is the best way to look at them. So one of the folders is home. And then off of home are several other subfolders. All right, so what I'm drawing for you is a hierarchical file system. Hierarchical meaning that, in fact, every node either is a terminal node or it has subnodes. Now, there are links that allow us to kind of violate that rule, but in fact, generally, it's a tree. In its integrity, it has to be a tree. So in every Linux system, now almost every one, Linux uses home as the home directory for all users. So on your Debian system, you'll have a home directory, and using your ASUWrite ID, there will be another folder. In my case, it's LINDQUIS. And that's my home directory, or my home folder. And then there are subdirectories for it. So let's just look at, for this class, SER, I recommend that you do that. You make that directory. and then at least 2 more major subdirectories, examples and assigns. So let's talk a little bit about the notion of a path. Path, or sometimes called a path name, in Unix is represented as if each of these edges or arcs is actually a slash, a forward slash. All right. So if I have a path name, let's just go ahead and do it in red. Slash. The first slash represents root. We don't actually write out root. Slash home. Slash Lindquist, Lindquis. That's a Unix thing. It used to be you couldn't have more than 8 characters, and that's how long I've been at ASU. Slash home, slash Lindquist, slash SER321. Another difference between Windows and Linux is that Linux, like Mac OS X, is case sensitive, meaning that capital SER321 is different than lowercase SER321. And actually, the same folder can have 2 different files of the same name, even if they're only differentiated by upper and lower case. Slash examples. So there's an example of what's called an absolute path name. Meaning that it starts from slash, from the root. All right, so each of these edges along the path from the root to the file that we're designating, in this case we're designating the examples file, each of the arcs along a path is designated by the slash. So from root, I follow slash to get to home, and then slash to go to Lindquist, and then from Lindquist to SER321 and so forth. An absolute path name is called an absolute path name because, in fact, it starts at the root. Okay, so now let's, just for the fun of it, let's go to Linux, and now let's connect it with the command line. So when you start up the command line, when you start up a new command line, it is in your home directory. So if I do the pwd command, which means print working directory, you can see that it prints out slash home slash Lindquist, and that's the absolute path for Lindquist. Right? That's the absolute path name to get to my home directory. Now another command is ls, which is like a dir, directory. Give me a directory. Tell me all of the files that exist within this folder. So I've got an apps, an assign1, a bin, a desktop, downloads, Mac home, meta information, mount Mac home, and an SER321. So now let's just go back to Emacs here. Oops, I can't do it that way. All right, so what it just told me is that if I look within the Lindquist directory, there are several other files that are within that directory. There's an apps file. Let me get back to black. And so forth. All right, so when I did the ls, it actually only gives me the files that are located at that different level. And what I want you to think of is that every time or at any moment, the bash command line interpreter is in what's called a current directory. So when I start up the command line interpreter, this is the current directory. And that introduces the notion of a relative path. Meaning that if my bash interpreter is in slash home slash Lindquist, then I can write SER321 slash assigns. And that is a path name that designates from the current directory where bash is currently pointed, it designates this assigned subdirectory. All right. So let me go back to Linux. All right, and you can see I do have an SER. So if I say ls SER321, you can see, I'm going to do, so there's an abbreviation that you can, well, LSDashL, forget about the abbreviation at this point. LSDashL gives me a long listing of everything in a given directory. So when I say LSDashL, this tells me everything in the Lindquist folder, and it shows me lots of information about it. It shows me how many bytes are in that file. So there is a file called Mount Mac Home, and it has 64 bytes in it. All the rest of these things are subfolders or are folders, so they all have 4096 because that's the size that gets allocated for it. Mac Home is actually a text file that contains some information about it. Contains a command, actually, a bash command. So I get the size in number of bytes, and I also get the modification time, the most recent modifications time. So you can see that my Mount Mac Home file was created on, or last modified on June 28th at 5:33 in the afternoon. So in addition to that, we have the owner, and then we also have a group. So this is saying that the Mount Mac Home file is owned by the user Lindquist, and it belongs to a group Lindquist. And why is that important? Well, all this stuff over here is actually its access. I've changed to black here. Access control. So the first three, D, R, W, X. All right, so D, red will work. D means that it's a directory. All right, so notice that the line up above for Mount Mac Home is not a directory. All right, there's a dash there instead of a D. Now these next three, I'm sorry, I didn't mean to do that. How do I get rid of it? No, not going to worry about it. So these three together, define for me. Oh, sorry, I got to figure out how to get rid of this thing. These three guys, we'll go back to see if I can do it this way. There we go, yeah. These three are access control for the owner. Meaning that the owner has read, write, and execute access. And the next three, so to point it out, this is going to be a lot of fun to erase all this stuff, but it's fun to draw it. All right, so this is, the first three are for the owner, the next three are for the group, and the last three are for the world, for everybody else, right? So this file has, every file has an owner. So in this case, the owner is Lindquist, and it also belongs to a group. And the group in this case is Lindquist. So it says that if an owner wants to access it, if Lindquist wants to access it, then Lindquist is allowed to read it, to write it, and to execute it. That's for the subdirectory. And if someone from the group wants to access it, they have the ability to read it and to execute it, but they cannot write it. And then the same thing for the world, they can only read it and execute it. All right, so I can change that and do whatever I want to with it. I don't know how to get rid of this, but we'll just kind of throw it away. Okay, so this long listing shows me all of the files that are within a given directory, and it also tells me for those files various information about them. All right, so one of the subdirectories is SER321, so let's go ahead and get this stuff out of the way and go down and take a look at SER321. Okay, so now within SER321, I can take a look at its contents, ls-l, SER321, the subdirectory. And within that subdirectory, you can see that I have an assignment subdirectory and an example subdirectory. So that leaves us with the notion of a relative path. And in general, for the command line processor, for bash, it gives me a prompt, right? That's this arrow. And then I enter a command. So the very first thing that I enter is the name of a command. In this case, I've asked it to execute the ls command, and everything else after the command are the arguments to the command. So for example, javac is the name of a command, so -d space dot, there's no Java files in here, star.java, and it'll give me a message, but this is invoking the javac command, which is the Java compile command, and it's passing to that Java compile command arguments that tell it where it's supposed to put the class files and what files it's supposed to compile. All right, so that's the typical command line process and the command line syntax. So you can see that it executed the javac command, and it says, hey, I couldn't find any source files, so you're going to have to figure out where your source files are and recorrect it and re-enter it. Okay, so now let me go back to this overhead. So we've talked about a hierarchical file system, named folders and files. We've talked about absolute path names, and we've also mentioned relative path names, right? So the bash processor is always in some command or always in some directory. We can change that directory, but whenever I enter a path, it can be relative to that directory. And I guess the only thing I haven't mentioned is name uniqueness within a folder. And let me just go back quickly and point that out. So home is a folder. And within home, there are subfolders in this case representing all of the users on this system. Well, for this system, there's only one user. But if there were 20 different users, name uniqueness within a given folder means that there can't be two users with the name Lindquist, which I just erased. In other words, at any given level within the tree or within any given directory, there can only be one name of a given sequence of characters. All right, so we have this notion of unique names within a given folder. Okay, so now the next thing is this notion of environment variables. Environment variables are useful for us for a couple different reasons. First of all, you probably in CST200 looked at the Java command, and you didn't use Java command -cp classes or -cp anything. You probably just did Java and then the name of your class. Well, because you were relying upon the existence of a class of an environment variable, and the name of that environment variable is class path. So there are several different environment variables. So here is a command line. There's a set command that allows you to set an environment variable, and if you don't give it any arguments, then it just tells you what all the environment variables are. So if I just type that, set, it gives me all of the different environment variables that are defined for bash. All right, so in this case, there's a temp directory. So here's the name of the environment variable, term session ID, and the value of that environment variable is what's on the right-hand side, right? So situation is that every environment variable can have a value. It doesn't have to have a value, but it does have a value. So the shell program is what it's called. This is the bash, /bin/bash. And if I go up, there's other ones. Manual path log name, so here's my login name. who I logged in as, and home directory. That's an important one right there. So home directory is users Lindquist. Actually, this shell is not on Linux. This is on, I just figured that out. This shell is actually running on my OS X machine. If I do the same thing, that's one of the reasons I like OS X so well. Set. All right, it gives me all of the environment variables that are set on Linux, and set pipe to less. This says give me all of the environment variables and take the output of that command. The vertical bar stands for pipe, and pipe it to another program called less. And less is a paging program. All right, so now I get the environment variables one page at a time. So as each time I push space, it goes down a separate page, and I can actually go to the very top and redo them or quit and get out of it. Okay, so the notion of an environment variable is especially important for one particular environment variable. There's another command called echo. So there's an environment variable. Let's do this. Set, pipe it to grep -I home. So these are all the environment variables that have home involved in it someplace. And in particular, there's the home environment variable /home/Lindquist. So let's do the same thing with path. All the environment variables that somehow have path involved in their definition. And there's too many of them. Sorry. Let's do it this way. Echo $path. So the $sign says what I'm going to type, what follows the $sign is an environment variable, and the dollar means expand the value of that variable. In other words, replace PATH with whatever's on the right-hand side of the equals, with whatever it's been defined to be. And echo says just print it out to the terminal. So I'll do this a couple times. So this says that my path environment variable is defined to be that string. All right, the path environment variable is defined to be that string. And I could actually say, well, let's just go on. Let's just go with what's the meaning of path. So you notice that the path environment variable is set to a bunch of components, which are absolute path names. Actually, they don't have to be absolute path names. They just are path names. So /home Lindquist bin /user local bin /user bin /bin. And what's the significance of path? Every time I enter a command, so javac -version, every time I enter the name of a command, bash has to have a way to find out where is the program javac. And what it does is search through the path environment variable. So another command line command is which, and it asks which javac, or which name, we say which and then the name of a program. It goes and searches for the executable program, in this case javac, and it prints out where it finds it. All right. So bash starts its search for javac. When I type javac-version, it has to invoke the javac command. And in order to do that, it goes to the path environment variable and searches each of the different segments of that path environment variable until it finds the javac command. So it goes to home Lindquist bin, user local bin, user bin, and you can see in this case it found javac in user bin. All right, so if I do LSDashL /user bin /javac, you can see that in fact it gives me a detailed listing of that file javac. And it turns out this is not a simple file, it's actually a link to another file in etc alternatives javac, but it shows you the access privileges for it. It shows you that in fact the owner is root and the group is root, and it was changed on the 23rd of July at 10, or excuse me, at what's the 10? I don't know what the 10 is, 1529. Okay, so the Java C command then is located there. So the other thing I want to show, I want to go back to my example up here. Why is this important, this directory structure important for programs like C++? Well, there is another subdirectory called USR, and within USR, there's always this, actually it's 4 instead of 3. There's always a bin, there's always a lib, there's always a share, and there's always an include. INCLUDE. And if you know, when we look at C++ programming, you should have already looked at it actually. In C++, or in C, you have for example, if I have a class called vector, I will have one file called vector.h. In C++, you can either call it H or HPP. We're going to call it HPP. And you'll also have another file called vector.cpp. There is an eraser. That's for people just like me. All right, vector.cpp. So vector.cpp contains all the implementation of the class vector, and vector.hpp contains all the information that's necessary in order to use the vector class. Well, all of the HPP files and corresponding .h files are stored in an include directory, and then actually in the corresponding lib directory there will be, not for code that you write, but for libraries that you use, there will be a corresponding lib in the lib directory. And then in the bin directory are all the corresponding executables. So this is the basic organization for Unix. There is, in the implementation of any Unix system, a group of subdirectories from user USR, user local, and others as well. You can do it anywhere you want. Where there's a bin directory, a lib directory, a share directory, and an include directory. And when you do a compile of a C++ program, you expect that the include directory has any of the classes that you're using associated with them, any of the library classes that you're using, and in the corresponding lib directory are the actual libraries themselves that contain the compiled versions of the actual code, implementation code. So the relationship between the Unix or Linux file system and C is actually very well ingrained and very traditional. So for example, if you have programs that are defined in here after they've been compiled and put into binary form, executable form, then they end up in the bin directory. And that's why when I say which Java C, I end up with a bin directory. And you'll notice that all of the paths all of the path segments in my path environment variable end in bin, meaning that that's where all the executable programs are stored. Here's user local games, and user games are two other ones that evidently with the default installation of Linux, there are some games that are installed. You could do a directory of those directories, do a listing of those directories, and you'd find what games come automatically with Linux. All right, so that's the background that I wanted to talk about in terms of bash programming, bash command line programming, and the notion of environment variable is actually a fairly important notion. So here are, and let's get rid of this thing. Here are some common, very common, and I think they're pretty close to all of the commands, the bash commands that we'll be using this directory, or this semester. And there's an example and sort of a definition. So what you see in blue is the name of the command and its generic syntax. And then in cases where it's not clear, there's an example. So there's a find command. which looks for files in a current directory. In this case, find all the files whose name is either ABC D or ABCE. And actually this syntax right here says not only, so the file name begins with ABC, it can be followed with either a D or an E and then anything else after it, right? So search the current and subdirectories for files beginning with ABCD or ABCE. grep-i author star.java. Search the content of all .java files in the current directory, right? So the grep command actually goes inside of files and it looks for a pattern match of a string. So it's looking for an author string inside of a Java file. All right, so if the TA in grading wants to find out if you've defined yourself to be the author of the submission files that you've generated, the TA can execute this command to find out whether or not all of the files contain an indication of who the author is. CD stands for change directory. So in this case, change to tilde courses SER321. Tilde is, as I mentioned before, is a shorthand for home, whatever your home directory, home environment variable is set to be. So change to $home/courses SER321. Either this form or this form are actually identical. All right, so then there's the notion of relative and absolute paths. Print working directory, already did one of those. In order to make a new directory, mkdir, so whatever you specify as the path will be made as a new directory. That actually should be a folder, mkdir, a folder. rm, a path pattern. This is to remove files. You don't want to do rm space star.star because it will remove all of the files. Star is a wildcard. But on the other hand, if you want to remove all of the source files, all the Java files, remove all the Java files from all subdirectories of the source directory, there's a command that will do that. Cat and less print out text files. Man is like a help command. Change mod, we'll actually take a look at that at some future example. Okay, so the next section is on Bash's startup. Every time that you start up a bash command, it goes and reads in the .bashrc file. So if you have anything that you want to have happen every time that you start a new bash, you can put it into that file. That file has to be in your home directory. So if you wanted to, you don't have to do it for this class. If you wanted to define java_home as an environment variable or ant_home, then in fact you'd put that into your .bashrc, so those environment variables, and then probably extend your path to include Java home and ant home. So that's all taken care of for you when you install ant and or Java. So let's not, oh yeah, I do want to do this. So there are some other things that are simplifications for working from the command line. And one of them is command line editing. So let's go back to, not you. So for example, I'm in my home directory and we know there's an SER321 in the home directory. I don't have to type it all. If I want to change into that directory, CD is a change directory, and then I do capital S. If I then hit tab, it will try and do command completion or file name completion. So it looks, in this case, in the current directory, and it looks for a file named SER321. And it works not only in the current directory, /u. All right, so what I typed in was CD/u, CD means change directory, CD/u, and then I hit tab. And if there's no other files in the root directory that begin with U, it knows how to complete it at that point. So tab says complete it, so it does. So IN would be for the include directory. All right, so I don't have to type all of a file name. I can use tab to do command completion. And it is a very convenient way to avoid having to do a lot of typing. Let's see, not that one. Let's go back to here. I also wanted to do redirection. So if I want to create a text file that has in it all of the names in the current directory, so right, if I do ls, that gives me the names in the current directory. I can do ls greater than temp.text. All right, what this is going to do is execute the ls command, which is going to generate this listing, apps, assign1, bin, desktop, and so forth. But instead of printing it on the terminal, it's actually going to send it to a file. All right, so after doing that, nothing comes out, but I now have a file named temp.text. Temp.text, and you can see that it has 80 bytes in it. And if I do cat temp.text, you can see that it has the names. All right, there's the apps subdirectory, there's the assign1 subdirectory, there's the bin subdirectory, and so forth. So redirection allows you to take the output of a command, and instead of having it come to the terminal, you actually can have it go to a file. So that's a very handy thing, actually, to avoid having to type things multiple times. And piping, we actually already took a look at piping. LSDashL, pipe it to grep -I for November. Here's an example. So take the output of ls-l and use it as the input for searching for text. And actually this is several different searches, so we're looking for different things. So what this command actually does is kind of a complex command, but it looks in the current directory and it looks for all files that were modified or created in November, and then it excludes files that were created in 2008 or 2009 as an example. So a fairly simple syntax with a very complex semantics, I guess is the right way to put it. Okay, so we already talked about path and bash RC. I'm not going to say anything more about that. And that takes us up to the next section, which is command line compilation and debugging. So this is the beginning of Unit 2. So before we end this session, the last thing I want to do is go back to this thing, execution environment for the lab exercise for Unit 1 and Unit 2 is assignment 1. And what it asks you to do is to complete the creation of your VirtualBox Debian Linux, and the directions for doing that are described on the assignment page. So there it is, configure your VirtualBox and Debian Wheezy Linux. It shows you what websites to do the downloads from, and then how to get things installed when you create the guest. And then actually after you've gotten Linux up and running, the software that you're going to need running on Linux is all described down here as well. So I want you, for assignment 1, it's actually to configure your VirtualBox Debian machine, and then to do a screenshot, which is a compilation and execution of a couple of example programs. So you'll be submitting a screenshot of an LX terminal session where you have executed and compiled and executed these programs and used some of the bash commands. Okay, so let's go ahead and leave it at that for this session. This is the end of session number 1 on bash and Linux.